I've shared the collab notebook with it's in the chat box. The link is given in the chat box. All of you are please requested to download the collab notebook and upload it in your drive so that we can move on with the code. So first we'll be discussing the market basket analysis uh, part of the session. I hope a priori algorithm is clear to you all. Girish sir did explain it very well. So I hope a priori algorithm is clear to you all. So we'll be first doing the a priori algorithm market basket analysis. So let's move on to the code. Hello. Is my screen?
Yeah, we can see
Oh,
your screen.
okay.
Start presenting. Yeah, thank you.
Okay. In order to run the a priori algorithm in Python, we have a package known as MLExtend. MLExtend stands for Machine Learning Extensions. So we'll be using the package known as MLExtend in order to run our code. So the first step is, if you're doing it in Colab, the first step is obviously to install the MLExtend package. So we'll have to install the MLExtend package first. So for that, we'll be doing pip install MLExtend. And that installs the MLExtend package in our Colab directory. Then the next step is to load the packages. So here you can see we have mlextend.frequentPatterns import a priori, wherein we are importing the a priori algorithm. Then we have mlextend.frequentPatterns import association rules. Now we need these association rules in order to create the association rules from our data set. So we have mlextend.frequentPatterns import a priori, then mlextend.frequentPatterns import association rules. Now the next step is to download our data set. Just a second, let me check. Okay, I think now you'll be able to access it. Are you able to access it now? Okay. So we have mlextend dot frequent pattern import a priori, then mlextend dot frequent pattern import association rules. And the next step is to import the data set from web. So we have a data set known as online retail.xlsx. This is a data set of Walmart. We hope you have heard of Walmart. It's a supermarket chain. So this is the data set from Walmart, the transaction data set from Walmart. So the next step is to download the data from archive.ics.uca repository. So we are downloading the data set from the UCA repository. So it will take time to download the data set. So run this code and the data set will be downloaded. So we are downloading the data set from UCA repository. Okay, let that be downloaded. I'll explain the code to you in the meantime. Kindly download this. All of you kindly download this in your Colab notebook. In the meantime, I'll explain the code to you. So our next step was to prepare the data. So we have downloaded the data set. So next step is to prepare the data. That is pre-process the data. Pre-process the data in order to perform the code. For that, the first step is we have a column known as description. So the description column has string data. That is, description column specifies what is the item that we are purchasing. So the item that we are purchasing, the item names might have white space in the beginning or the end. So we need to strip those white spaces and get only the name of the item that we need to purchase. So for that, we will be using myRetailData.description equals to myRetailData.description.str.strip. The stripping of the white spaces from the beginning and end of the item name. Now the next step is we have invoice number. Another column in the data set is invoice number. We are removing the duplicate values from the invoice. So we are removing the duplicate invoices available in our data. The next step is we have to convert the invoice into a string. Now, why do we need to convert the invoice to a string is that the algorithm that you're using, the a priori algorithm that you're using only supports string type of invoice numbers. Hence, we need to convert the invoice number into string category. So now we have seen two columns, description and invoice number. Now also, there is a transaction known as credit transaction available. So for our purpose, we won't be considering the credit transaction. We will be just considering the others. So we'll remove the credit transactions and then we display. So let me see if it is download. Just a second. There is some problem in downloading the data. Are you able to download the data set? Is anybody able to? Okay. So it seems there's some problem with my network. Shall I continue explaining the code? Is it okay? Seems there is some problem with my network, so I'm not able to download the data set in here. Shall I continue explaining the code? Okay, I'll do that. So we have prepared our data set. So with this, we have prepared our data set. We have cleaned our data set. Now, what we'll be doing is we'll be listing. So as I said, this is from Walmart. Now, Walmart is a huge supermarket chain in many countries. It's available in many countries. So we'll be listing out the countries and we'll be listing out the number of Walmart based on the country, number of transactions based on the country. So my retail data within quotes country dot value counts list the number of transactions performed in each country based on each country. Okay, here mine is downloaded now. So we have cleaned the data. We have removed white spaces from the description part. Now we'll be listing out the data set based on the country. So here you can see United Kingdom has close to close to 5 lakh transactions. Germany has 9,000 transactions performed and so on. So you can see, if you want to see how many transactions are there in total, we'll be calling myretaildata.shape. And when we run this, you can see that there is close to 550K transactions available. So in this, we won't be performing market basket analysis for every single country. Rather, for the whole 550K, we won't be doing that. It will take a long time and you won't be able to run it in a single go right now. So instead, we'll be choosing a single kind. We'll be choosing a subset from the data set that we have. So here, I'll be creating a basket. I'll be creating a subset of a basket in which I'll be calling my retail data within bracket, my retail data country equals to Germany. So here I'm calling just the data from the Germany. I'm extracting just the data from Germany, group by invoice number, description, quantity, and then dot sum, unstack, reset index, fill the not a number values are filled with zeros and index is set to invoice number. So you can see the data set that is being created. The data set created has the item names. These are the item names. Each individual item name is there as the column name. Each individual item is set as the column name, and then invoice numbers are set as the row index values. And then each 00 value that we see corresponding to item represents the quantity of the things that are purchased. So here everything is 00, but let me see. We search for 50 transactions. Yeah, here you can see 24. So it means that in this particular invoice, that particular item, the particular item that we have checked, which is a colored Boy pen, has been purchased 24 times in that particular invoice number. So we created our data set in such a manner for our algorithm to perform. Now the next step is here, as you just saw, the quantity value is listed. The sum of quantities in each invoice is listed. So instead of that, we need to write it in 1-0 manner, because our algorithm only accepts 1-0 values. So we need to convert it to 1-0 values. So for that, we need to encode our data set into 1 or 0s. That is being done here. So we have defined a function to convert all positive values to either 1. If there is a positive value, it will be converted to 1. If there is nothing, it will be converted to 0. We are converting it to 1-0 values, and then we are encoding my basket to my basket set. And there is another value known as postage. Postage is one of the items that is being purchased. Postage has negligible value, hence we are removing the postage. You can either keep it or remove it, that is up to you. Postage has negligible value, hence I'm dropping that from our item list. So when we run the code, all the values are converted to 1s and 0s. Now we'll be training our model. So is it clear till here? Is it clear till here? Do you have any doubt till here? Hello? Do you have any doubt? Okay, fine. We'll move on. The next step is to train the model. So to train my model, I'll be calling my frequent item sets. Then I'll be calling the function a priori. Within parentheses, I'll be specifying my basket set. That is the data set that I just created. The formatted data set that I just created. Then minimum support value. Here I'm specifying the minimum support value, the percentage of minimum support value that needs to be considered. So here I'm specifying the minimum support as 0.05. Then use columns equals to true. I need to extract the column names as well. So I need to specify use column names equals to true. Then this generates my frequent item set. When I print it, I can see that these are the frequent item sets in our data set. These are the frequent item sets generated. Retro spot tea set ceramic 11 piece, retro spot party bag plus sticker. This is a 2 item set, this is a 1 item set, this is also 1 item set, and so on. So the frequent item sets are generated. Now the next step is to generate the association rule from the frequent item set that we just got. So we got the frequent item set. We specified the minimum support value and we got the frequent item set. Now the next step is to generate the association rules from the frequent item sets that we got. So to do that, I'll call the function association rules. Within parentheses, I'll pass the frequent item sets that we just got. Then we specify the metric as confidence. Now confidence is specified as the metric that we'll be using in order to generate the association rules. So the metric is specified as confidence and minimum threshold value is set as 0.5. Now when I run this, my association rules are generated. Now I'll be listing the top 100 association rules generated. So you can see that we have this is the antecedent in the row. This is the consequent. Okay. This is the antecedent. This is the consequent, and we have the support for corresponding values. We have the antecedent support. We have the consequent support. Then we have the support value, confidence value. Can anyone tell me what is lift, leverage, and conviction? What is lift, leverage, and conviction? Have you heard of it before? What is lift, leverage, and conviction? Have you heard of it before? Hello? Okay. Lift, leverage, and convictions are also metrics to evaluate the frequent item sets, similar to that of support and confidence, but they are not most commonly used. Lift can be specified as confidence of A given C divided by support of C. Then leverage is given as support of A given C minus support of A into support of C. Conviction is given as 1 minus support of C divided by 1 minus confidence of A to C. Now, high conviction means that consequent is highly dependent on the antecedent. You can Google those values actually. These are measures similar to that of support and confidence that is used to evaluate the association rules or the frequent item sets. Lift, leverage, and conviction are also similar to that of support and confidence that is used to evaluate the association rules that we created. So here you can see that every rule that is generated has a confidence value greater than that of either equal to 0.5 or greater than 0.5. First one is 0.58, 0.57, 0.53, 0.60, 0.50. It can be either equal to 0.5 or greater than 0.5. So that is how we generate the association rules. Now, suppose I want for a single item, I want to find the values of a single item. So my basket says round snack box of 4 woodland occurs around 112 times. Now my basket says space box lunch occurs around 47 times. So to find the values of individual items, we can check it this way. My basket says round snack boxes of set of 4 woodland sum, and we call it, we get it 112 times it has occurred. My basket says space boy lunchbox of sum, we get it that it has occurred 47 times. Now we can filter the rules based on conditions specified. So here I have the rules. Here I'm specifying. Now earlier I specified that my confidence value should be 0.5. Here I'm specifying that the confidence, let's say confidence value is greater than 0.75. So only 2 rules are generated which has confidence value greater than 0.75. So here, or you can call combinations of rules actually. And my rules, there is no such rule that satisfies both these conditions. Since there is no such rule that satisfies both these conditions. So we have 2 rules that satisfies both these conditions and we get the result. Is the a priori algorithm clear? Do you have any doubts? Okay, I'll give you 5 minutes. Have you completed till here, or should I give you 5 minutes to try out everything so that I can move on to the collaborative filtering now? Should I give you 5 minutes or say 10 minutes to try out the whole code and ask me any doubt if you have? Do you need 5 minutes to try out the code? Fine. So let's move on to collaborative filtering next. So I'll share the code with you, collaborative filtering. Just a second, let me just share the code with you. Okay. So before I start, let me just briefly go through what I'm going to do in the session, and then we'll move on to our code. So I'll briefly, just very briefly explain what is recommender system and how collaborative filtering works. Just very briefly, I know Girish sir has explained it very well. So just very briefly, I'll be going to explain what exactly I am trying to do, and then we'll move on to the code. So as you know, we'll be discussing recommender system today. So what is a recommender system? Basically a system that is used to recommend items. So you might have used recommender system. Actually, you're using recommender system. If you are a person who uses internet, you will obviously have been using recommender system many times. There are online stores, online stores that we have, Flipkart, Amazon, Myntra, or even Google for that matter. When we search for items in Google, the ads that we see all are based on recommender systems. So recommender systems tend to substantially increase the sales in online stores. That is why recommender systems are being used. So there are basically 2 approaches to recommender systems: content-based filtering and collaborative filtering, known as social filtering as well. So this is an example of book recommendation system. So here you can see user has either liked or disliked certain set of books. So we give this these values, that is based on the user profile, users like or dislike. We give this value to a machine learning algorithm which creates a user profile. And based on this user profile, when we get values that have not been evaluated before, we can evaluate those values based on the user profile that is created. So that is how basic recommender systems works. Now we'll move on to collaborative filtering. Now how collaborative filtering works is, we have a main database of user ratings of variety of items. So for each individual item, we find a set of users who have similar items. Like for every single user, suppose we have a user A who likes items, say pen and pencil. So we try to find users, say C, D, E, F, who have liked items similar to that of user A, who like items similar to that of user A. And if there is an item that has not been rated by user A, but has been rated by the user C, D, E, and F, we can find what the ratings of C, D, and F are. And based on those values, we can find the missing rating, or we can recommend that value to user A. So that is how collaborative filtering works. This is a basic example of how collaborative filtering works. We have values. So we need to find whether this particular user will like video games. So you can see that this user and this user are supposedly neighbors of this users, or have similar likes and dislikes to this particular user. So based on that, we evaluated that this user will dislike the video game. So we can move on to the code. Let me just share the code with you. Okay. So the first step is, we have to import the libraries that we'll be using. Is my screen visible? My screen visible? Okay. So we'll be using a movie lens dataset. Movie lens dataset is a dataset which has ratings of movies, and we'll be using that dataset in order to do our collaborative filtering. Actually, collaborative filtering can be done in two ways: user-based collaborative filtering and item-based collaborative filtering. We'll be doing both of those today. So I'll explain that as we move on. Actually, it's a simple concept. User-based collaborative filtering is where you try to find users who have similar tastes and preferences based on past rating they have given to same items. Whereas in item-based collaborative filtering, you group items as similar items, and then if a user likes a particular item, they are suggested items that are similar to those. So that is user-based and item-based collaborative filtering. So we'll be first looking into user-based collaborative filtering. First step is, we have to import the Panda as library. Then we have the NumPy library. Then we have to import matplotlib.pyplot in order to plot the result that we get. Then obviously we are mounting our Google Drive. Okay, I'll have to share this data set with you. Just a second. Okay. So here I've mounted my Google Drive, and now I'm accessing my data set in here. So the data set is known as ratings.csv. Ratings.csv has the rating values, movie lens rating values. Then I'm printing the contents of movie lens rating values. So it has 4 columns. First is user ID corresponding to each user, then the movie ID. Then we have ratings, the rating that user has given to each individual movie. And then we have the timestamp, as in when the user gave the rating. So we display the contents of ratings, and then we display the ratings.shape. So you can see that around 1 lakh, more than 1 lakh values are ratings are available in our rating movie lens data set. So when we print the ratings.info, we can see that user ID is of type int, movie ID is of type int, rating is of type float, and timestamp is of type integer. Now, so we have loaded the data set. Next step is, we have to split the data set into training and test. So in order to do that, so we have sklearn.model selection, import training test split. So here we are splitting the data set into training and test set. So we have ratings, the data set that we have. Then we are specifying the test size as 0.30. That is 70% to training and 30% of the data set to test. Then we are giving a random seed value, that is 42. Now we are printing the shape of train and test value. So here you can see that 70,000, some 70K, around 70K values have given to test set and 30K values have been given to test set. 70K value to training set and 30K value to test set. Then we have to pivot the ratings table that we have based on movie features. So the movies are become the column values and users become the row values, and the ratings are the values corresponding to the rows and columns. So here we are pivoting the table such that the movie IDs become the column values. The number of movie IDs become the column values. So we have around 8,556 movies are there. So movie values become the column values, and then number of users become 5. We have 5 users. 5 users are there. No, user ID is 5. So we have 5 rows and we have around 8,566 columns. And the ratings each user provided for each movie is given as the values corresponding to rows and columns. So we pivot the table such that we have movies as features. Now, what we have to do is we have to create a copy of train and test set. Now, we create a data set known as a dummy train and dummy test. What it will be used for is dummy train will be used later for prediction of movies that has not been rated by user. Suppose there are movies that has not been rated by any user. So in order to do that, dummy train will be used and dummy test will be used for evaluation. So in dummy train, to ignore the movies that are rated by user, we will be marked it as 0 during prediction. Movies not rated by users is marked as 1 for prediction. And in dummy test, the movies not rated by users are marked as 0 for evaluation. So we create a dummy train and dummy test, and then we pivot it exactly as we did for the train and test set before, ratings table before. We pivot the values for dummy test and dummy train. Then, as Girish sir told you, we use similarity measures in order to evaluate the similarity between. So first we'll be using user to user similarity metrics. We'll be using user-based collaborative filtering. First step is user-based collaborative filtering. So for that, we need to use a similarity measure which tells us how similar one user is to other users. We'll create a subset of users which are similar to each other. So in order to do that, though that subset is known as neighborhood of the users, in order to do that, we need a similarity measure. So we can either use Pearson correlation or cosine similarity or standard deviation or any other metrics for that matter. But here in our example, we'll be using cosine similarity. So I'll be importing cosine similarity from sklearn.metrics.pairwise, import cosine similarity. And I'll be computing the cosine similarity value. User similarity equals to cosine similarity within parentheses user data. That is, we are computing the user similarity matrix using the cosine similarity as a similarity measure between the users. And if there is not a number value, it will be replaced with 0. So this is the cosine similarity matrix that we obtain. Now we'll be predicting the user ratings on movies. So in order to predict the user ratings on movies, what we'll be doing is we'll be first computing the product between user similarity and user data, and then That is divided by the correlation value that we obtain. User similarity and user data divided by the sum of correlation value. Sum of user similarity and user data divided by the correlation values is how we compute how we predict the values, predict whether a particular user should watch a movie or not. So first we have to find the dot product between user similarity and user data. I hope this is clear. This has been explained to you in the equation that Girish sir taught you. While he was teaching collaborative filtering, the mathematical part of it has been explained to you by Girish sir. I hope this is clear. I hope you have no doubt. If you have any doubt, please feel free to stop me in between and ask away. Do you have any doubt till here? So we have user predicted ratings, which are computed as np dot dot. We are computing the dot matrix of dot product of user similarity and user data. So we obtain the user predicted ratings metric as the result. So the shape of user predicted ratings would be 610, 8566. Then, so we do not want to recommend the same movie to a user who has already watched that movie. So in order to do that, we have to ignore the movies already rated by the user. That is where the dummy train metrics will be used. So for that, we'll multiply user predicted ratings by dummy train. So in dummy train, we have specified one for the movies that are already viewed by the users. So those movies will be ignored when user predicted ratings are multiplied by dummy train. So when we obtain the result, this will be the result that we obtain. It will ignore the movies that are already viewed by or it will specify the movies that are already viewed by the users, and only those movies that are not viewed by the users will have ratings corresponding to it. Then in order to display the top 5 movies, we will have user final rating dot location. So we are trying to find the number of top 5 movie recommendations for the user 42. We have a user whose ID is 42. So in order to find the recommendations for user, top 5 recommendations for the user 42, what we do is user final ratings dot I location, that is 42nd location. Then we are sorting the values in descending order. Then 0 to 5, that is we have to use the top 5 movies. So when we run that, we see that movie 480, movie 150, 457, 593, and movie 1. These are the 5 movies recommended for the users. We can give different values in here, and if we want top 7 movies, we can give that, and we'll get the top 7 movies for that particular user. So this is how user-based collaborative filtering is done. Is there any doubt in user-based collaborative filtering? So as I told you, user-based collaborative filtering is, in user-based collaborative filtering, you have to find users with similar tastes and preferences based on past ratings they have given to same items. And based on that similarity, we compute the similarity based on correlation or cosine similarity. And based on that ratings, we compute the recommendation. Now, in item-based collaborative filtering, it is actually item-based collaborative filtering is the method that is heavily used by companies such as Amazon and different companies that uses the recommender systems. So, in user-based collaborative filtering, what you do is you measure the similarity between the users. The basic idea is that similar users are likely to have similar tastes, whereas in item-based collaborative filtering, you calculate the similarity between various items or products, and next, the rating that a particular user will give to an item is predicted by taking the rating that the user has given to similar items. So suppose a user has given a rating to, say, a notebook. So we'll see similar items that are similar to that notebook. And if a user has given this particular rating to that particular item, the user tends to, or user probably will purchase similar items. You can see that in Amazon actually. When we purchase things in Amazon, you might have seen. If you purchase a notebook, automatically pen, pencil, rubber, and everything else is recommended by Amazon. That uses item-based collaborative filtering, wherein when you purchase one single item, the items that are similar to it are recommended to you based on the item-based collaborative filtering. That is, when you purchase one single item, all the items that are similar to it and all the items that there's a probable chance that the user might purchase are recommended to the user. That is how item-based collaborative filtering works. So you need to remember that this is the method that is most commonly used by the big companies that we have. So in order to do item-based collaborative filtering, we'll be pivoting based on the movie ID actually. Instead of pivoting based on user ID, we'll be pivoting based on the movie ID. So movie ID is specified, then we have the user ID. So the list of users again, we have 610 users. The columns will represent the users and the rows will represent the ratings corresponding to the users. So each row value will represent the rating corresponds user has given to the particular movie. And then we compute the similarity metrics. Obviously, we'll be using cosine similarity here as well. So in the same way we did previously, we will be computing the cosine similarity value. And after computing the cosine similarity value, we'll compute the dot product of movie features and item similarity. We'll compute the dot product of movie features and item similarity. And we get the metrics as a result. Then we see the shape of the item predicted. So here the shape will be 610, 8566. 610 represents the number of users, 8566 represents the number of movies. Dummy train also has the same values. Then we call np.multiply for cell by cell multiplication. So here what we are doing is, in the previous example in user ratings, we saw that we won't recommend the movies that the user has already seen. Same thing is done here. We are not recommending the movies that are already seen by the. If there are more number of zeros, as in I didn't actually get your question. In user ID and movie ID, are you trying to say if it is a sparse matrix, should you exclude the zeros and multiply only the values? Actually, this is a basic dot product that we are doing. If you have an optimized way to perform that dot product, surely you can do that. If you have an optimized way to perform the dot product, you can surely do that. This is a basic dot product that we are using. We have not optimized it in any way. So if you have more number of zeros and if you have a way to perform the dot product in an optimized manner, definitely you can go for it. You don't have to follow the exact method. Basic dot product, a basic multiplication is being performed here. So you can do that in any way you want. It's not necessary that you have to use this particular function itself. You can do it in any way you want. You can do it in an optimized manner. If you have an optimized way to do it, you can definitely do it in an optimized manner. You don't have to follow exactly this method. You can do it in an optimized manner if you want. Okay. So shall I continue? Okay. Yeah. Yeah. So we'll be doing a cell by cell multiplication. We'll be calling np.multiply item predicted rating, then dummy train. What this does is it removes the movies that users have already seen. It removes the ratings of movies that users have already seen, and only those movies that the user has not seen till now will be there in the metrics, the user predicted metrics, so that the movies that user has already seen won't be recommended to him again. Then we are again trying the based on item based prediction, we are again trying the movie recommendations for user 42. So when we try the movie recommendations for user 42 based on item based collaborative filtering, what we get is movie IDs for 480, 457, 2, 150, and 185 are being predicted to the user. So you can see that in the earlier case, when we used user-based prediction, these were not the movies. Some of them are repeating again, but these are not the exact movies that were predicted when we used user-based collaborative filtering. So in user-based collaborative filtering and in item-based collaborative filtering, the movies that are being recommended are different. There are some changes in the movies that are recommended. So till here, we have done the training part. Now we move on to the evaluation part. So we have trained the algorithm and we have recommendations for individual users. Now we need to test these recommendations for users. That is for our test data set. So in order to evaluate for evaluate user to user similarity for our test data set, what we do is we compute the test cosine similarity for test users. We have the test user features. So we pivot in the same way as we did earlier. We pivot the users based on user ID and movie ID. And then we compute the cosine similarity for test users and remove the nota number values. So we obtain the matrix 6 by 10 into 6 by 10 matrix. That is the user matrix we obtain, user feature matrix we obtain. And then we compute the user predicted rating. And then when we test it based on movies that are already predicted by the users. So we have movies that are already predicted by the users. So we test these values based on movies that are already predicted by the users. So we obtain the result. Now, when we, this is the description of our ratings that we obtain. That is the result of ratings that we obtain. This is the description of the ratings that we obtain. So we need to normalize the rating values to be in the range 0.5 to 5. So we normalize using min-max scalar. I hope min-max scalar is clear to you. You have learned it before, right? Are you familiar with min-max scalar? Are you familiar with min-max? Okay, fine. Okay. So we use min-max scalar to normalize the values. The rating values are in different ranges, so we need to bring it to range 0.5 to 5. So we normalize the values and bring it to the range 0.5 to 5. And then we find the number of total number of not a number values. NP dot count non-zero is not a number in prediction values. So we have 3021 not a number values. So this is the test data set that we displayed. We have these many not a number values in it. So using that, we find the root mean square error value. Using the number of not a number values that we obtain, we find the root mean square error in the test data set. That is the recommendations in test data set. We find the root mean square based on the not a number values in the data set. So what we do is we find the difference between test and predicted values into 2. That is square of test and predicted values. Then we sum of squared errors. We find the value of sum of squared errors. And then we find the square root of the sum of squared errors divided by total number of not a number values. And we get the error value as 1.5642 and so on. And mean absolute square error is obtained as 1.21. So it means that our average, that on an average, user-based recommendation engine is making an error of 1.2 in predicting the user rating. Now, in the similar way, we can find the prediction for item to item similarity. In item to item, item-based collaborative filtering, what we do is in the similar way, we pivot the values. Then we compute the cosine similarity, then remove the not a number values. Then we find the dot product. Then we have the dummy test value. So we are testing on movies that are already rated by the user. So item predicted ratings test and dummy test. We find the multiply between item predicted rating test and dummy test, and we obtain the result. We can see the mean value, the standard deviation mean value, 25% for form type, 50%, 75% the max values of ratings dataset. Then we use a min-max scaler to normalize the data. And we find the total number of not a number values. You can see the not a number values in the data set. And we compute the root mean square error and the mean absolute error. So it means that when we use item-based recommendation engine, we get an error of 2.21. And when we use the user-based recommendation, we get an error of 1.2. So in our example that we just saw, it is here that user-based recommendation provides a better result than that of item-based recommendation. Rather than item-based collaborative filtering, user-based, in this example, in the movie lens dataset example that we just tried out, user-based collaborative filtering tends to provide better results than that of item-based collaborative filtering. Okay. Thank you, sir.
Thank you, ma'am. Thanks for the wonderful session.